Hello everyone. Today we shall talk about DeepSeek R1, the latest open source AI model designed for code generation and reasoning. A Chinese open source model that's not only challenging OpenAI's dominance but reshaping the entire AI landscape. Stick around because we shall talk about what makes DeepSeek R1 better than other AI coding models and how can we run it locally on our machine. For a long time, OpenAI has been overpriced, charging developers as much as $200 per month. But not anymore. DeepSeek R1 has arrived, and guess what? It is 20 to 26 times cheaper than OpenAI. Therefore, OpenAI might have to rethink about their pricing strategy. DeepSeek shook the stock market, causing $100 billion loss for US tech companies. DeepSeek's cut price challenge wiped out $600 billion in Nvidia's market value. DeepSeek isn't a big giant company like Google or OpenAI. DeepSeek started as a small company with limited funding, with only 200 employees versus OpenAI's 4,000 employees, and still managed to build a model that competes with the best. Not only competes but also beats the best. DeepSeek has published a very interesting paper. It is one of the best written research paper on AI, providing a detailed and well-structured insight into their approach. They talk about DeepSeek R1 as the first generation of reasoning model, a model which thinks before providing the solution, using large-scale enforcement learning without relying on supervised fine-tuning as a preliminary step. They also provide a comparison of performance with different AI models like OpenAI. Like they are providing accuracy comparison with OpenAI model here. They have also discussed some unsuccessful attempts they have been making to develop this AI model. Here they are discussing few mathematical concepts they have been using for that. It reminds me my A-level mathematics books, which was the only book I used to like from the entire syllabus. This model is built on reinforcement learning, which makes it smarter over time. This AI model is so much popular that US President Donald Trump has called DeepSeek R1 as a wake-up call for US tech giants. To see how DeepSeek R1 beats other AI model, we go to browser and type lastexam.ai. We'll go to this site and see a comparison of accuracy and calibration error among different AI models. And if we see DeepSeek accuracy is 9.4, while GPT-4 has 3.1. So DeepSeek significantly dominates over GPT-4. And then calibration error percentage, DeepSeek has 81.8% while GPT 92.5. There are different AI learning model types like supervised learning, unsupervised learning, and reinforcement learning. If we talk about traditional supervised learning, it's think of like a student learning from a textbook. They are given question and answers, memorize them, and use that knowledge to solve similar problems. Unsupervised learning is like a student exploring patterns on their own without explicit answers, trying to group similar things based on similarities. Now, reinforcement learning is completely different. It's like teaching a dog tricks using rewards. Instead of memorizing answers, the model learns by doing, getting rewarded for good actions and penalized for bad ones. Over time, it figures out the best way to achieve a goal through trial and error. This is why DeepSeek R1 is unique. It skips supervised fine tuning and relies on reinforcement learning, making it more powerful in reasoning and decision making. Unlike ChatGPT, you can run DeepSeek R1 100% privately on your own machine. First, open Ollama.com. Ollama allows you to run LLMs, large language models, on your local machine. Click on download, download for Windows. Okay, Ollama setup is downloaded, so let's install it. Okay, while Ollama is being installed, let me tell you a very interesting fact. DeepSeek spent 5.6 million on computing power for its base model. which might sound like a huge amount, but in the world of AI, where companies like OpenAI and Google spend hundreds of millions or even billions on training their models, this is actually a remarkably low investment. Despite this, DeepSeek R1 has managed to achieve exceptional performance. Okay, Ollama is installed, so let's run it. Okay, now I will go to models and click on DeepSeek R1. Okay, there we have different models. Okay, I will select the smallest model here. Okay, I will copy this Ollama command and go to command prompt. I paste command here and run it. It will start pulling manifest information related to DeepSeek. The first time when we run it, it will take some time because first it downloads the model and then run it. But next time when execute it, it will run a bit faster based upon your CPU power, based upon your GPU power. It's showing almost 30 minutes. So we wait for its download to complete. Okay, our DeepSeek model is ready to run locally. When running it locally, the model is downloaded to your computer, and when now running this model, it will utilize your PC's computational resources like CPU, GPU, and RAM to generate responses. Unlike cloud-based AI models that rely on external servers, running DeepSeek R1 locally ensures 100% privacy and allows you to use the model offline without depending on an internet connection. However, the performance will depend on your system's hardware capabilities, right? And now I give it some command like write a merge sort algorithm in Java program. I run it and it has started working. Beautiful, isn't it? I don't have very powerful hardware, but it's still working decently. Now I skip to write a Java program to get factorial of a number. You see, it's also showing so here that I am thinking, right? So it has concluded its thinking between these lines, and that's a program for factorial. And that's great. I like it. Okay, if we go on DeepSeek page and scroll down, we see some comparison of DeepSeek with some other AI models regarding architecture, params, a lot of other attributes. Okay, so that's it for today. If you found this video helpful, don't forget to like this video, subscribe for more content, and hit the bell icon so you never miss an update. Thanks for watching.